The last exercise, we found the area between a curve and the x-axis. Today we're going to look at what we need to do if we're enclosing the area between a curve and the y-axis. So we can go either way. The process isn't terribly difficult. If we are looking at the area to the y-axis, instead of integrating the function of x, we need to integrate the function of y. So integrate with respect to y, and that's what the bit in the brackets stands for. It's just shorthand for with respect to. So when we're asked to find the area enclosed by these curves, so we've got y is equal to x squared, the y-axis, and the line y is equal to 9. Your first step, just like it would be if we were finding an area to the x-axis, you need to draw it. You need to know what it is you're talking about. Y is equal to x squared is a parabola. We've got the line y is equal to 9. So you want to put that in there. And then it's the area between the axis and that curve. Alright, so you can see the area is going from y is equal to 0 up to y is equal to 9, because we're integrating with respect to y. We need to know what the y variables are. Okay. Now the other thing that we need to consider is the fact that we've been given the function as y is equal to x squared. So this is a function in x, not a function in y. We need to know what x is in terms of y in order to integrate it. So if y is equal to x squared, then x must be equal to the square root of y. We don't need to worry about the negative. Have a look at your graph. We're talking between the curve and the y-axis. We only need to consider the positive for this one. Okay, so then the integral that we need to evaluate to find this area. Well, generally we do the x parameters, but because we're integrating with respect to y, we do the y. So it goes from 0 to 9 of the square root of y. And then it's dy, because we are integrating with respect to y, not with x. Okay? Now remember, I can integrate it as long as it's power, so everything from here is exactly what we've done before. Alright, so this is the integral from 0 to 9 of y to the power of a half dy. And that is, well, add 1 to your power, so it's 3 over 2. Bring your power down the front. And then from 9 to 0. Okay, so once I do my substitution there, now you can put that straight into a calculator because it is fairly complicated. You know, we're 9 and we're taking the square root, which is 3, and then we're cubing it, which is 27, and then we're taking 2/3 of it. So that's 18. The 0 is easy. So it's equal to 18 square units. Okay, so we'll have a look at another example. We want to know the area enclosed by y is equal to x cubed, the y-axis, and the lines y is equal to -1 and y is equal to 8. So again, first step is to draw a graph. You want to know what it is you're doing. So y is equal to x cubed looks like that, or sort of like that. That was pretty poor, but anyway. We need the line y is equal to -1 and y is equal to 8, which is going to be up there. So the area enclosed between them is that part there and that part there. So we have two areas. The one to the right of the y-axis is going to be positive, the one to the left of the y-axis is going to be negative, so we still need two integrals. This is all exactly the same as what we were doing before. Okay? We also need to consider the fact that y has been given as x cubed. So if y is equal to x cubed, what is x equal to? Well, it's equal to the cubed root of y. Okay, so that's what we need to integrate. So again, remember we said, tell them what you're doing. So I'm going to call this area 1, I'm going to call this one area 2, and then work them out. I want you to pause the recording and have a go, and then come back and check your answer. So area 1, well that is the integral from -1 to 0. of, now what is the cube root of y? Well, that's y to the power of a third, and then dy, which I know how to integrate. I'm going to add 1 to the power. What's a third plus 1? It is not 2/3. Do not fall for that trap. Okay, 4/3. And so then we need the 3/4. And that one is from -1 to 0. The substitution there is pretty easy. You put 0 in, you get 0. You put in the -1. And we get -3/4. So we end up with an answer of -3/4. But we know that area can only be positive. The negative just tells us it's to the left of the axis. Okay, so what about our second area? So area 2, we find the integral from 0 to 8 of exactly the same thing. So again, the part inside the brackets is exactly the same. But now we are going from 0 to 8. So when you substitute 8 in, you end up with 12. We already know 0, we did that, so it's equal to 12. So the area to the left is 3/4 units squared, and the area to the right is 12 square units. So my total area is equal to 12 3/4 square units. So there's nothing particularly new. You just have to remember your parameters have to relate to y, not to x, and you have to integrate the function of y, not the function of x. All right, that's what you need to do exercise 3.7. Good luck, and I'll see you in class.